Energy creates about 75% of our climate emissions. But energy is so fundamental to everything we do. Even though energy is only 4% of global GDP, the economy grinds to a halt without it.
If we're going to stabilize the climate and stop undermining the life support systems of the planet, we need to redesign the system so that we're not digging up billions of tons of fossil fuels and burning them every year because we're harnessing the clean energy around us. But there's a certain fear of this transition.
The early estimates of the energy transition were extremely high. Now, we're actually saying something very different.
It is cheaper to be using cleaner technology than dirty technology.
We estimate that the savings will be the order of $12 trillion. So it's very likely that this will make energy cheaper than it's ever been in history.
When you disrupt a major sector that is literally worth trillions of the global economy, it's going to be exciting.
I've been working on problems of prediction my whole life. And making intelligent decisions about how to cope with climate change is dependent on being able to anticipate a decade or two into the future, what are the costs of energy technologies going to be. Our paper looks at the historical behavior of energy technologies over the last century. And the key message is that on one hand, you have energy technologies like fossil fuels, which cost about the same as they did a century ago. But solar energy, for example, which had its debut with the Vanguard satellite in 1958, now costs about a 5,000th of what it cost then. We think this is very likely to continue. And if you take the kind of discount rates that people have widely proposed are sensible, then it's the order of $12 trillion cheaper. And we know that because we've tested the methods on more than 50 different technologies. By pretending we were in the past and didn't know the future, we're saying we actually save money. So there is no cost. It's a net benefit, and that'll have many positive effects on the world. Almost all of the published papers in the academic literature have systematically made projections that have assumed renewable energy would be deployed at a much slower rate than it has been deployed, and that the costs would drop much more slowly. They're systematically wrong, and wrong by a substantial amount. And that makes a big difference in terms of how quickly we make the transition.
In many instances, the costs of going to a cleaner future are not high. They're not even low. They're negative.
We're arguing that it's an opportunity. It's something that's going to save us all money. As this sinks in, and as we get more evidence that this transition is happening quickly and cheaply, people will start to pile on the bandwagon, and suddenly everybody will be eager to participate in making the transition happen. Means that even if it weren't for climate change, it would still be really valuable to pursue the green energy transition and do it quickly. I think this reframes the whole debate.
I think we're going to see quite some big changes in the next decade. There's a vast amount of energy all around us all the time that we can capture and start to use. So I'd be stunned if we don't see an exponential increase in renewable energy in the energy system over the coming decades. Now, some of those innovations will take longer than 10 years to come to fruition. But the ideas that are already proven in the lab and now coming out of the lab into pilot and demonstration phases. It's cheaper, it's better, it's higher tech, just do it anyway.
And so the businesses that position themselves to be leaders in this transition are going to profit by it. The consumers are going to profit by it. So we just win by having to pay less for things that we use all the time. Might even be a win-win-win-win scenario. If solar energy and wind and batteries and hydrogen electrolyzers become very cheap, then not only do we have cheap energy, we have non-volatile energy prices because their prices won't fluctuate like fossil fuels do. We have clean energy that doesn't produce pollution. the ability that any country that wants it can have energy security. And then the biggest win of all is we prevent climate change from being worse than it's already going to be. We should really think of nature as a garden that we have to tend. And so we need to be good custodians of that garden.
Five years ago, there were more than 1 billion people in the world without energy. Now actually that's reduced to about 800 million, and that's because of remote solar. My name is Professor Henry Snaith, and I'm the co-founder and chief scientific officer at Oxford PV. I founded Oxford PV from the work I was doing in the university. We discovered these perovskite materials that produce power at a much higher efficiency than any other material we'd looked at. When we started looking at this material, it was delivering over 10% efficiency, which was already competitive with some commercial PV products. That's risen up to over 25% efficiency just as a single absorber layer. We can actually combine it with silicon by making a so-called tandem device. And if you could make an infinite number of junctions, you could get up to around 83% efficiency.
Current silicon photovoltaic panels convert between 15 to 20% of captured sunlight into electricity. With a single layer of perovskite over conventional solar cells, Oxford PV have already achieved a record-breaking 28% efficiency and are developing a multi-layered cell with 37% efficiency.
Since our initial discoveries in 2012, the whole world has woken up to perovskites, and there's probably 10,000 researchers across the world in all the different institutions working on these materials. It's the first major change to standard PV since the silicon cell was first discovered in the 1950s. The prospect for long-term advancement of getting close to 100% efficiency is actually feasible.
The perovskite layers are extremely thin, less than 1 micrometer in thickness, which is a 40th of the thickness of our human hair on the top there.
The module is actually a relatively small fraction of the overall deployment cost. Most of the cost is in the land, it's in the metal frames to hold the modules, which means that if you want to make solar cheaper, if you just keep driving down the cost of the module, there's diminishing returns. Whereas if you could double the power output for the module for the same price, you would halve the cost straight away.
These go through all sorts of harsh environmental stress tests to make sure that the fundamental stability of the cells and materials inside is going to last for the 25 years required for real-world operation.
Farming amounts to about half our land use. For the UK, if we needed to produce all our power from photovoltaics, we'd need about 2% of our land at 20% efficient modules, which are the sort of best modules of today. Of course, if that goes up to 40% efficiency, then you need only 1% of our land. So compared to how much land we need for feeding ourselves, it's a very small fraction.
This is a solar simulator. It does what it says on the tin. It simulates sunlight. This is so that we can test our cells in the lab for characterizing their efficiency and performance without having to wait for a sunny day.
In Brandenburg, Germany, Oxford PV is building its first volume factory. Opening in 2021, the facility will initially have a capacity of 125 megawatts, with a target capacity of over 1 gigawatt by 2024.
The factory that we're building here that opens next year and in 2021 actually is only big enough to produce power for about 36,000 homes. Our plans are to build much larger factories in the future so that we can build at the scale that's required to have an impact on the energy generation for the world. I'm Chris Case, and I'm the Chief Technology Officer at Oxford PV. Oxford PV's perovskite technology is the most significant solar technology in 65 years. It's going to make energy cheaper. And cheaper energy means more access of energy to everyone. Cheaper energy means a faster adoption and move to an all-electric future. And an all-electric future is the only way to save this planet.
Each one of these is a solar cell. So actually you can peek in and see the solar cells. They come in stacks, 200 at a time, being transferred into the tool that produces this very thin coating. The rate is roughly 1 every 2 seconds, about 2,400 solar cells per hour. Here's one of the films that we produce. It's being tested on a piece of glass, and we shine a laser through it so we can measure its characteristics. Normally that film would be put on one of these silicon solar cells and would make the high-performing perovskite solar cell.
Change is not happening fast enough to arrest climate change. The targets are very aggressive, but 50% of energy generated by photovoltaics by 2050 is simply not fast enough. We do need to do something to move solar cells and solar energy adoption faster. And this technology from Oxford PV is one of those ways to do that.
We need to act now. We need to embrace new technologies like perovskite and drive them forward at a pace that has to have an urgency to it.
An all-electric future is amazingly exciting because of the changes that it can do for the world. I mean, just think, when electricity becomes so inexpensive, you do things that were unimaginable before.
Ultimately, if perovskites remain the most efficient, easiest to process semiconductor material for photovoltaics, then there's absolutely no reason why they can't produce most of our global power demand.
Remember, Thomas Edison had this very famous quote, I place my bet on the sun and solar energy. I just only hope we don't wait until oil and coal run out before we tackle it.
Space-based solar power is the concept of putting large arrays of solar panels up in space and transmitting that electricity wirelessly down to Earth. In space, because you see the sun all the time, you get 24/7 power, and because there's no weather, no seasons, no night, you get 13 times more instant energy. You can instantaneously switch the beam between any point within the field of view, so a third of the Earth's surface from a single satellite. You get this incredible, scalable, continuous energy source. Space-based solar power can be a hugely important part of our future energy mix in helping us move away from fossil fuels. Space is our adjacent economic sphere. It's already had a huge impact on the way we understand and manage our environment and the climate. And I think it opens up just a huge range of fantastic possibilities for the next generation. I'm Sam Adlen. I'm co-CEO of Space Solar, where we're developing and commercializing space-based solar power, leveraging the abundant energy in space to provide clean, affordable power to markets on Earth.
This is an incredible artifact of space-based solar power. It's the original journal from astounding science fiction, where Asimov, as a very young man, wrote his short story Reason, which has the first description of space-based solar power beaming to other worlds. He was an unbelievable science fiction writer. A lot of his predictions have come true.
So space-based solar power really first came into people's consciousness through people like Asimov. And then ever since the 60s, NASA and others have studied space-based solar power, and it's always been considered technically viable. It's effectively the concept of putting large arrays of solar panels up in space. That converts the sun's energy into electricity. You transmit that in a low power density beam, so it's designed to be safe, down to receiving antenna, a rectifying antenna on Earth. It's a bit like a fruit net on poles. Our smallest system is a 30 megawatt system. It's a 400 meter diameter. So that's about 4 times the size of the International Space Station. Then our largest gigawatt scale, 650 megawatt system, is 1.4 kilometers diameter. To put that in context, a couple of gigawatts is a typical power station and provides city scale power. Now, one of the challenges with space solar power is as you go around the orbit, you need to both point at the sun and the Earth all the time, changing the angle. So most designs, or many designs, have a large mechanical rotating joint, which is heavy. Our first demonstrator is called Harrier. It's a half-meter demonstrator of our core technologies.
It is the world's first type of a 3D retrodirective phased array. We do something slightly different at Space Solar. We're using this helix shape, and this helix allows us to electronically steer the beam. So Harrier is this first attempt at showing full 360-degree wireless power transmission using this helix shape. This enables us to both point at the sun, we fix ourselves at the sun, but electronically we can steer the beam in order to keep pointing at the Earth.
The 5 things that space solar can help with on Earth are providing affordable, abundant energy. It can help us create a range of different new large infrastructure to meet a range of different benefits like communications or data centers in space. It can help us optimize our energy systems because of this ability to flexibly switch the beam to anywhere within the field of view, so you can reduce overall energy system costs internationally. It can help in terms of driving future jobs, a bright future for the next generation. And then importantly, it can help us democratize energy access. Often the form of power that's relied upon most are diesel generators. And with smaller modular receiving antennas, there's the opportunity to provide a far more sustainable alternative to these solutions. We've got huge challenges with the intermittency of renewables. Space solar power, it can help some of the intermittent renewables like offshore wind and terrestrial solar by providing that power that balances the production from those systems when the wind's not blowing or the sun's not shining. So with the change in launch costs that we're about to see, space-based solar power is now incredibly economically viable. It's important that we introduce new energy sources because frankly energy demand is just skyrocketing. And what space solar power can do because of its compelling economics is ultimately really reduce the cost of energy to consumers. The scalability of space-based solar power is one of its really key features, and now we're in a position to go on our roadmap, which next sees ground-to-air power beaming in 18 months, an in-space demonstration of kilowatt-scale power in 3 years' time, and a first 30-megawatt system providing commercial power in 5 years' time from a single Starship launch. We can start with a different approach, and actually making sure sustainability is embedded from the start is key. The UK's got some huge potential and leadership in certain areas. And space solar power, with the change in launch costs, with the increasing energy demand, it's now the time for space-based solar power in space to become a huge contributor to meeting our energy needs. We live in times of great change, but also great opportunity.
The sun provides the basis for almost all forms of life, and it underpins our food system. There's a great need for food production, there's also a great need for solar energy, but there's a limited amount of land. Do we use our land for solar energy or do we use it to grow food? There is a solution.
Agrivoltaics can be a game changer.
One of the amazing things about this technology is it allows us to integrate solar panels into agricultural land, meaning that land doesn't need to be converted to solar panel use. It can be used for agricultural outputs as well. Over the past decade, we've seen a rapid increase in agrivoltaics research and development in East Asia, in Europe, in the US, of course in East Africa with ours as well. The main reason for that is because some of the greatest benefits that can be had from agrivoltaic systems could be achieved in those regions. I'm Richard Randall Boggis, a research scientist working to design the agrivoltaic systems for the different contexts. I've worked on projects in East Africa and now I'm working on them in Norway, which are completely contrasting situations. The way that the agrivoltaic system works in East Africa, the solar panels are raised above cropland while still using the land underneath for farming.
In Kenya, traditionally we have been doing the solar panel, and the land beneath the panels, we leave it bare. And considering the way we are having a lot of land fragmentation in our country, any space that you're having as a farmer, you're supposed to be utilizing it to ensure that you're having food security. If people adopt agrivoltaics, they're able to harness power, they're able to harvest water, at the same time growing crops under the solar panels. We have experimented with different types of horticultural crops like tomatoes, peppers. We do French beans for exports, and also the indigenous vegetables, the likes of managu, konde. And what we have been able to know is that crops grown beneath the panel tend to be more productive, that is in terms of the quality and the quantity. Having the shade minimizes the amount of water that is being lost by the plant, which means you're going to use less water to grow the crops under the agrivoltaic system. And apart from that, you're also harvesting the rainwater from the panels, ensuring that we will be having water throughout the production cycle.
So we have gutters that are attached to the lower edge of the solar panels, which means that we can collect the rainwater that's running off the solar panels in a large storage tank and then use it later on during periods of drought. And also, because solar panels are modular and they can be deployed at different scales and also off-grid, it allows for rural communities currently without access to electricity to receive those benefits as well.
In the agrivoltaics farm, 70% of the power we are consuming in a day is generated from the renewable energy. We are running heavy machinery. The pumps are pumping water maybe 12 hours in a day. For an ordinary farmer, they are able to harness power and they are able to earn a livelihood through selling the crops or even using the crops for their own consumption.
Here, it shows them access to the benefits that electrically powered technology can bring. This could mean a make it or break it for a farmer's livelihood.
We are sharing the knowledge with the community and with any other person who comes to Latte to learn about the agrivoltaic system, be able to understand how it works and the benefit it has to the environment and also to the agricultural production in ensuring food safety.
That matters for those farmers, it matters for those communities, and it matters for us because our food system is interconnected, it's global. So anything that's going to affect those food systems, it affects everybody. Our research and research conducted by others around the world is helping to inform how agrivoltaics can best be implemented and also help us learn what not to do. Here in Norway, it's an organic farm. The previous growing season was grass that was used to feed livestock. They also grow cereals here. But current legislation states that we can't change agricultural land into solar parks. But that means that solar developers are having to turn to other areas, such as forest land. The vertical bifacial systems that we can see here mean that solar panels could be integrated into agricultural land and reduce deforestation. How an agrivoltaic system is designed will completely depend on the local context, including the agricultural practices. From an economic perspective, the systems have to make sense. We could have systems that are raised up with the panels spaced apart above cropland. These panels could be on trackers to track the sun or even tilt away from the sun to let more sunlight through to the underlying crops. We could have semi-transparent panels that let some sunlight through. We can even have some solar panels that are wavelength selective. So those panels will use some wavelengths of light to produce electricity and other wavelengths of light will be passed through to the underlying crops to maximize their crop production. And now we're looking into how agrivoltaic systems can be implemented with robotic farming, taking the technology to the next level. Scaled up, agrivoltaics can see large capacity of renewable electricity generation while agricultural practices are still maintained or even improved.
Technology and nature can coexist and it will make the work easier and also the production will be higher.
There are now thousands of agrivoltaic systems implemented around the world.
It's time we change the way we do our farming and make our farming to be smart and thinking that what could be the impact on our food production or on our food security.
Mais dans le même temps, lorsqu'on va à l'intérieur du pays, dans les zones rurales, il y a à peine 6% des gens qui avaient accès à l'électricité. Les enfants ne peuvent pas étudier le soir. Dans les dispensaires et les centres de santé, ils n'ont pas de quoi réfrigérer en fait les produits. Donc c'est une question de développement plus qu'une question d'électricité en fait.
An estimated 600 million people in sub-Saharan Africa still do not have access to electricity, or 50% of the overall population. In Togo, the figure is only 43%. The At2ER agency was set up by the Togolese government to bring renewable energy to even the most remote locations. Its goal is to create universal energy access by 2030.
Je suis Chegoun Bakary, conseiller du président de la République. Le président de la République a décidé de mettre en place en fait un fonds pour l'électrification des ménages, qui est une première mondiale, parce qu'en fait aujourd'hui au Togo, tous les ménages ruraux qui décident de passer du kérosène ou de la bougie au kit solaire ont tous les mois une subvention de 2000 francs CFA qui est l'équivalent de $4 par mois. On a pris le temps de construire des bases solides et aujourd'hui on est dans la phase de déploiement de tout cela. En faisant les calculs, on s'est rendu compte qu'il y avait un peu moins de 5000 villages au Togo qui n'avaient pas accès à l'électricité aujourd'hui.
Donc il faut vraiment trouver une solution intégrée, pas aller secteur par secteur.
Pour chaque village, on est allé calculer ce qu'on appelle le least cost of electricity en fait, mais où il y a une faible densité de population et donc pour lesquels il n'y a pas de sens d'amener le réseau. Donc ce seront sûrement des kits solaires en fait. Il y a par contre des villages qui sont éloignés du réseau mais où il y a une forte densité de population où on va mettre des mini-grids. D'éclairage public. Il faut qu'on apporte l'électricité pour l'éclairage public, il faut qu'on puisse électrifier les écoles, il faut qu'on puisse électrifier les centres de santé en fait. On s'est aussi rendu compte qu'il y a des gens qui vivent dans des zones où il y a l'électricité aujourd'hui et donc pour qu'ils soient raccordés au réseau national en fait. Donc c'est vraiment l'objectif, c'était de dire comment est-ce qu'on fait pour que les gens dans les zones rurales aussi puissent se sentir concernés par la croissance économique qu'on a au niveau des villes en fait.
Non, nous estimons qu'aujourd'hui la donne a changé, apporter juste de l'énergie ne suffit pas. Il faut aussi donner les moyens aux ménages de pouvoir payer le service énergétique. Et donc il faut développer de l'économie locale.
On veut que tout le monde ait accès à l'électricité.
Residential solar in India is a sleeping giant. Right now, our electricity infrastructure mostly consists of big coal plants spread across the country.
As the Indian government targets a rooftop solar capacity of 40 gigawatts by 2022, Solar Labs looks to increase the pace of installations by offering automated computer analysis of rooftop capacities.
My name is Siddharth Gangal and I'm the founder and CEO of the Solar Labs. Solar Labs' vision is to accelerate solar adoption through technology. There is huge capacity for installation of solar panels on top of existing rooftops, but the process of installation of solar is a severe limitation. So as you can see, this is the customer's rooftop. The engineer will take all the measurements. So for example, they'll take all the dimensions in meters or feet inch. Then they will input this into our software. Once those measurements are inputted, then a live replica of this entire roof is created in the solar labs. Then our software automatically figures out where to place the panels in the most optimized way so as to ensure that we get the maximum amount of solar energy coming on. That is basically what the software will do. It will tell you exactly how to lay this entire system.
We want to become one-stop solution for all the kinds of services that our customer may need. What we are doing is not creating some new process. What we are doing is actually automating a process that was already happening manually. And now, with the help of the software, reducing the time. Earlier, it used to take 2 to 3 days, and now it can be done in 15-20 minutes.
So the entire design, right, of 150 panels, the software from the start decided where those panels will be. Then it decided, okay, if this is the inverter, this group of panels would be connected to this inverter. And then basically all the connections as they happen here, then the wiring diagrams are constructed automatically within the software. So we know exactly which group of panels would be strung to which inverter. A very key part of energy decentralization will be solar power. Any residents can get their own solar plant. In India, we are going to go towards the concept of microgrids. A microgrid is a collection of individual energy sources in a local area. Many people with larger rooftops could be generators and then provide electricity. Other houses can then purchase electricity from this local microgrid. It's very hard to do that for a wind or nuclear plant. Residents can start contributing directly to solving climate change. In the US, residential solar was the force that drove solar adoption. Residential solar happened first, and then it moved on to commercial and industrial. In India, we're going the opposite way. In India, we don't have a formal credit system. Hence, it becomes very difficult for solar companies to offer solar on a RESCO model, in which the solar company would finance the system. This model is the most common model of solar adoption across the world. In any country, that's the way it's accelerated. But in India, we don't have the finance capability and the credit checks required to fulfill it. Solar Labs will support hundreds of thousands of solar businesses, drive installations over millions of homes in the coming decade. And in the future, it will also provide awareness and provide basic data to the consumers directly so that they can understand what the financial benefit for their roof will be. There are multiple ways that technology can add value. Everything is pointed towards solar and renewable energy growth. Our technology can help accelerate the move towards solar power in India and the world.
Energy systems are really quite magical because think of all the things we would be having to do if we didn't have energy. If you wake up every day and had an energy-free day, how different would it look? Our lives are so fundamentally shifted by energy. And it has for a long time felt that that was a very good thing. The byproduct of that, using fossil fuels particularly, has to produce a load of carbon, which is then going to change our weather systems and cause other challenges for us as a society. And we now need to figure out how we decarbonise that if we want to continue on that pathway. We see this advent of trying to bring in renewable fuels, but also I think we can see some fundamental shifts in the research. Change like this will never be smooth, but in bumpiness there is opportunity as well. My name's Juliet Davenport. I set up a renewable energy company in the late 90s.
The new future, clean energy.
To supply clean electricity to homes and businesses. As we go forward now, we are still seeing a growth in energy demand. 84% of that growth coming from renewables. We're going to have to change the way we use energy to make this shift to electrification. The old energy system had been set up for very large centralized power stations. So it has been as much about the technology itself as it is about a system change, and kind of understanding how these new technologies begin to integrate with a system that was built in a completely different world. Renewables covers a whole range of technologies. You've got some of the more traditional ones like large-scale hydro, which are great and fantastic and very flexible, but there aren't that many places you can build large hydropower stations. Next one you've got up is wind. Onshore wind is one of the cheapest technologies to deploy worldwide. And then you've got solar, it's sort of cousin next door. Then you start to look at some of the biomass technology. So that's biogas, which is quite often a waste fuel, produced when you use waste food or waste agricultural products and create gas off them. And you can use that either for heating or for generating electricity. When you bring all those technologies together, there are going to be periods when, for example, there's not very much wind and you've still got demand. And so actually what you want something is to be able to smooth that. And that's where storage plays a role. So you've got obviously just classic lithium ions, batteries sort of that we see in our laptop, in our cars. Then you've got hydrogen, which again is a storage technology. And then fusion, which is the way that the sun generates its power, heat. It's a technology that's had a lot of investment over the years. We're beginning to see some little green shoots in there. So there's some interesting ways that you might mash all these technologies together. There's a renewables background. I have a vision of, for example, the UK being almost 100% renewably powered. We have 40% of Europe's wind resource altogether. And so my view of what the UK will look like is we'll have probably a lot of offshore wind, some onshore wind. There'll be a reasonable amount of solar, both ground mount, but also rooftop. Now that may be a slightly different vision than somebody else in the energy transition. What I absolutely know is I think that we will see one big shift that people don't really talk about, is that the way we demand our energy will shift. We can see a world where actually individual households and businesses become part of the system and actually help the system respond to the challenges of bringing lots of renewables onto it. But in addition to dynamic demand and self-generation, we are also going to need some very big system changes. I think there's a lot of companies who are already in the fossil sector who have started those journeys. This is becoming real. You're now beginning to see that type of investment that I haven't seen before. What I find fascinating is that for a long time we've measured the efficiency of processes through a financial lens. By bringing a sustainability lens in, you can see efficiency in a completely different way. And actually you can get economic return. It's just you never saw it through the other lens because you would never think about re-engineering a whole problem. And that is what I find fascinating, is I think sustainability could bring a huge amount of innovation that we just haven't seen before.
I think fusion is one of the greatest challenges that humanity has ever undertaken. In many ways, it could completely transform society as we know it. No longer is energy about who has access to what they can dig out of the ground, which is basically how our whole society works today. It would be about who has access to technology. It's a completely different paradigm for where we get the electricity that powers our lives. Delivering fusion is not just about understanding the technical challenges. We have to build a whole sector here, a whole industry. That's the next step for fusion. That's the next horizon. So I came to fusion 20 years ago now because I want to change the world. I want to make a difference to the world in what I think is the most existential threat that we face, which is addressing climate change. I remain convinced 20 years later that the world needs fusion, that we need sustainable ways of producing low carbon electricity, and I'm still on that journey. My name is Ian Chapman. I'm the Chief Executive of the UK Atomic Energy Authority. The UK Atomic Energy Authority is the UK's national laboratory for the development of fusion. So we're here to do fundamental research into fusion. Because we are a publicly owned organisation, our mission is very much about working with industrial partners, trying to develop a whole landscape, actually build a sector that can then deliver fusion power plants in the future. I, like pretty much everybody that works here, we all came here to make society a better place and provide low carbon energy provision for our children. When that happens, and it's a when, not if, when that happens, I will have fulfilled my life ambition. Fusion, I think, is at an inflection point. Fusion in many ways is the ultimate energy source, right? It's low carbon, it doesn't produce any carbon, it's inherently safe, inherently sustainable, and it's baseload, so it's on all the time, you're not waiting for the wind to blow or the sun to shine. Another hugely attractive concept of fusion, and it is no more than a concept at the moment, is that you could use fusion for electricity production. Because you have so much heat, you could use that really high grade heat for a bunch of industrial processes. So instead of using that heat to turn a turbine, you use the heat to produce glass or cement or hydrogen or ammonia, or things that currently we only produce by burning fossil fuels. So in many ways, that's sort of the panacea, right? It sounds like a perfect energy source, but it's really hard, because to make fusion happen, you have to take two types of hydrogen, so deuterium and tritium, just two isotopes of hydrogen, and force them close enough that they fuse together and release energy. We have never actually built a plant which produces electricity out. So we now have to get to that point, right, where we now need to build prototype power plants that actually put net electrical out onto the grid, powers the lights. There are some challenges to overcome. I break those challenges into two categories. Firstly, there are technical challenges to overcome, and then secondly, we have to actually stand up a whole industry, build a whole ecosystem. If I first of all address the technical challenges, think about what you're doing here. You're taking a fuel and making it 10 times hotter than the centre of the sun. You have to really think cleverly about how you're going to extract the heat. As it fuses, that fuel releases neutrons. It will actually, a power plant will be the most intense source of neutrons on the planet. And as those neutrons move through the material that you've built the plant from, the steel, they will change the properties of that steel, change its lifetime and actually degrade it. That's a big challenge. You have to think about how you're going to keep putting fuel in. The establishment and the supply of tritium is a big challenge. And then lastly, that's a pretty unforgiving environment. To maintain the machine, you need some pretty complex robotics. Now, any one of those things is a hard challenge. On the second side, on the establishing an industry, again, fusion is a really exciting place to work because of the multifaceted nature of that problem. So we are at the nexus of lots of different industries, going from aerospace to space to oil and gas to nuclear, and we have to bring all of that together to make a new industry, to make companies that can build fusion power plants. And that's a really exciting challenge, but it's also a challenge. That's a long way into the future, I'm afraid, but we are making real tangible progress. Fusion will be capital intensive. It will require many billions and probably tens of billions to build prototype power plants. As you build 10 power plants and then you build 100 power plants, for sure the costs will come down, because as soon as you start doing things on volume, costs come down. But the first ones will be big and expensive, and they will for sure require government subsidy, and they will require market incentivization. You could contend, well, if we're going to meet net zero by 2050, surely we should invest in the other technologies that stand a chance of being rolled out in the next 15 years. I'll give you two reasons why that's not the case. The first is that not only do you need to get to net zero by 2050, you need to sustain it. We should want everybody to have access to high quality of life, which means electricity and energy provision is fundamental to that. That will only happen if we can provide more energy than we do today. So in order to sustain net zero targets, I think fusion is going to be essential. The second reason why you should be investing in fusion today is because you get spillover benefits into other sectors, including into other energy products. I think investment would be more catalysed if we said, you're not just betting on a 30-year horizon, but you're already going to get benefits in the next 5 years because we're developing technology which can be applied in other sectors. That 20-year journey through fusion has been an incredible experience. I've seen so many things change. We've broken world records here for fusion energy released in JET, the world's biggest fusion experiment today. We've seen other world records be broken in other places in the US, and new magnets and new robotics and all sorts of new technology being delivered into the sector. We really do have optimism that we can now take that step. We can now take that leap forward and build prototype power plants that actually produce net electrical. One of the things that brought me to fusion is not just about that it's low carbon and it's sustainable, it's about that it's equitable. It would work in all jurisdictions. Every country in the world can have fusion power. It's not about who has access to wind or who's near the equator and has access to sun or who can dig coal out the ground. Everybody can have it. It's completely equitable, completely just. And that's really exciting. It could completely revolutionise the whole energy market.
Fusion really is the same process that you see in the sun or stars at night. And we're replicating that on Earth. We're just a short distance away from what was the hottest temperature in the solar system. When I first decided to do the job, it was a family decision taken with my 2 daughters. And it's really thinking about their future and their kids' future of why we're doing all this. This will transform humanity in the future, and that's fusion for me. Are we rolling? Ready to go? Yeah. My name is Warwick Matthews, and I'm CEO of Tokamak Energy. We're heading into a climate dead end. And fusion is definitely a way out of that dead end. It offers not only green baseload power for electricity, but also the means to decarbonise some of the hardest to abate industries. Sustainable fuels, steel, petrochemicals. These industries don't need electricity so much, they need high-grade heat. Fusion is an excellent source of that. But it's also what will enable AI. And we're starting to see companies emerge that will have the same power demand as small countries. For their independent power needs, they need an answer like fusion. At our facility here, just outside of Oxford, is our machine, ST40, a spherical tokamak, 40 centimetre major radius, that's what that means. The tokamak is a fusion machine that confines plasma in a magnetic field. Not a thing of future fantasy. But actually R&D we're doing here today. So let me introduce you to ST40. This is our spherical tokamak fusion machine. And this is an incredible machine. Where we're standing in February of 2022, we're just a short distance away from what was the hottest temperature in the solar system on that day, when ST40 achieved 100 million degrees Celsius plasma ion temperature. So 100 million degrees is an incredible number, right? Why that was so significant for ST40, our own device, is it's the threshold temperature for fusion to occur. Until you achieve that number, you're not causing the reaction to occur, and you're not producing the energy that will ultimately power the plant in the future. Think of ST40 as containing a small star or a sun here on Earth. You're using very, very powerful magnets to compress and shape a plasma. ST40 is a R&D device. We put in enough power to make fusion happen in ST40 that could otherwise, for that short fraction of a second, be powering 50,000 homes. So it takes a lot of energy. It's not a power generating device. We're learning from it. And we believe when we scale that up to future machines, it is the most efficient, most compact device to provide the best economic answer for fusion power. ST40 is a deuterium machine, and deuterium is one of those isotopes of hydrogen that you use in a fusion device. Fusion itself is such an efficient fuel and process. This is a small machine, granted, but here are the fuel tanks for ST40. And maybe you can get a scale of the size of the canisters of deuterium that we're using.
So just this amount of fuel in this small fuel tank allows you to produce temperatures exceeding the sun?
Yes, yeah. We're doing that with an impressively small amount of deuterium fuel. There's different levels of knowledge in every country around the world. And we need to educate people and show them just how big this prize is, but also bust some of the myths that exist out there. Everything from believing it's the same as nuclear fission to creating black holes in the future and a lot of trepidation. Whereas essentially a fusion device has an inherent fail-safe built into it. We're creating these extraordinary conditions I've described in order to make things fuse together that desperately don't want to do that. Fusion wants to stop. Given the opportunity, it will stop. And at any one point in time, you have a minute amount, 1 or 2 grams of fuel in that machine. It doesn't have the fuel to continue the reaction. And that's why it's a very different process. People should feel comfortable about this being in their area, more than comfortable, kind of privileged to have fusion in their area. And it's why we should regulate it differently as well. All important steps for the future. The race is on. So what was a government lab-driven R&D is now being picked up by private fusion companies. Now we're starting to see the two blend together in public-private partnerships. When you have individual companies with investors behind them, they want to drive for the finishing line and they want to win. But fusion is a mix of, it's co-opetition. There's competition and collaboration in the same way. I think all companies know they cannot answer every technology question themselves. And so we need to define our role very clearly, have very clear technology we're developing, but be open to collaboration with bigger partners. And that's definitely our mindset at Tokamak Energy. We don't think we'll have your answer in 2 years' time. We are very ambitious though, and we support the Milestone program in the US, which is there to deliver a pilot plant in 10 years' time. First pilot plant in 10 years. So we're now into the early mid-30s, 2030s. The 2040s is when this really scales. And so we are dealing with a technology that is there to hit decarbonisation goals in 2050. And that's where our ambitions need to be in countries around the world for fusion.
I don't see a future to a truly sustainable energy economy without fusion energy. There's and continues to be a lot of focus on deploying renewables. By the mid-2030s, that's going to start to change. Fusion is the power of the stars. It's what powers the sun, and it really is the most powerful form of energy in the entire universe. I think the biggest myth is that fusion is still a long way off, but things are happening so quickly in the fusion sector right now, it's almost hard to keep up. We are in a position to actually bring fusion to the energy markets, and that will really open the door to a practical way of achieving net zero carbon emissions. There really is a real opportunity to put fusion on the power grid in the mid-2030s. Fusion is in the transition from basic research and development to commercialization. This is a really exciting time for fusion energy, the most powerful form of energy in the entire universe. And it's very simple. At the conditions at the center of the star, you achieve the temperatures and pressures needed to combine the very lightest atoms, hydrogen, and turn them into helium. And in that process of nuclear fusion, you release an incredible amount of energy. And that energy can be harnessed to provide the power that's going to support the energy transition to a more sustainable future. The center of the sun is at 15 million degrees Celsius and more than 100 billion atmospheres. And so creating those conditions on Earth in a way that is repeatable has been the challenge that has faced fusion and the science of fusion for more than half a century. My name is Chris Mowry, and I am the CEO of Type 1 Energy. It's a private fusion company, and I also have the honor of chairing the SMI's Fusion Task Force. The fusion process is completely clean. It emits no carbon dioxide, no greenhouse gases. There's no long-term nuclear waste from this. It is a completely safe process. And of course, it creates a very significant amount of energy. The fuel source for fusion, for the most common type of fusion, is really ultimately water. And actually, if you think about it, from that perspective, fusion is unique in that it has no geographic dependency, and it's on demand. It's not an intermittent source of energy the way many renewables are. So in that way, it's a great complement to the future mix of energy, which certainly will have renewables as part of it. The types of fusion that basically try to create this very, very high temperature gas, really a plasma, typically they're contained inside of a magnetic bottle. There have been a lot of advances in this regard that are actually things that can allow us to make more practical, more compact fusion machines. High temperature superconducting magnets, which create very strong magnetic fields that let us hold this fusion plasma in a smaller configuration, and therefore let us make machines that are smaller and more compact. There's a number of different approaches to fusion energy, but ultimately, with the advent of modern supercomputing, we've really now had the capability to actually predict and model how the fusion process works and design machines that can actually reproduce that. The science of fusion practically is mature. We can actually now pivot to focusing on the commercialization, which is taking those processes that have been developed in laboratories and industrializing them. It's almost a handoff, if you will, from the pure scientists to the engineers. A lot of people ask when fusion is going to be ready to scale. Fusion will be ready when society needs it to be ready. By the mid-2030s, the maximum practical amount of renewables on power grids is going to be achieved, and so that's why we're focused on deploying the first fusion pilot power plants over the next decade, so that by the second half of the 2030s, we're really ready to scale fusion energy aggressively and globally in order to continue the transition to net zero carbon. The commercialization of fusion energy is going to require a significant amount of capital. Society needs to mobilize resources in order to make the shift from currently how it produces energy, which is fossil fuel intensive. The underlying policies which govern the energy industry need to be reshaped by governments around the world. If you want to have this incredible technology in the portfolio of energy mix in the future, we're going to have to invest in it. The pathway for fusion to really be commercialized and adopted at scale is now for the fusion industry to connect itself to the broader value chain of companies and organizations. So this is everything from the supply chain of materials and minerals and equipment to the asset managers, to the owners and off-takers, to regulators, to the financing and to the insurance, all of the things that really have to come together in this broader value chain. There have been a number of really, really important milestones that have been achieved over the past 5 years that really have opened the door to commercializing fusion energy over the next decade. I believe that we are in a position to actually bring fusion to the energy markets, and that will really open the door to achieving net zero carbon emissions and completing this energy transition journey.
Humans are a relatively young species. We've been here about 200,000 years. But the rest of nature has been here 3.8 billion years. And in that time has learned to do everything without harm to the planet. We're at a point now where we are starting to see some of the unintended consequences of the way we've been living here as a young species. It's time for us to figure out how to live here in a way that enhances this place. And the best place to look for that is the organisms that have already figured out how to do that, how to live here gracefully over the long haul. Biomimicry is innovation inspired by nature.
Biomimicry means looking to the natural world to see how it has evolved and applying that to real-world problems, and in our case, to help make existing renewable energy products better and more effective.
Being a pioneer means looking to nature and also to engineering in a creative way, looking outside the box to discover novel solutions maybe people have not come up with yet.
We're trying to solve the world's climate issues by making renewable energy better than it is today.
There's a really good chance that nature has already whittled the design down to something that's optimized through natural selection and that process of evolution. So we harness and take advantage of that, and we say we have a 3 billion year head start on R&D. Biorenewables is a biologically inspired engineering and design firm, and we develop technologies in the renewable energy industry. We exclusively practice biomimicry for all of the innovations that we bring to market. So we're focused primarily on the wind industry.
The power cone that we're in development on is something that does not exist in the industry today. It's dealing with a problem called rotor root leakage that no one has managed to solve.
So as the airflow is coming into the middle of the turbine, it's actually diving in towards the middle, not being efficient. And so we looked at the aerodynamics of a falling maple seed to try and inform the geometry of the power cone. When a maple seed is falling, it falls at a certain coning angle. It's a self-stabilizing biological rotor, which is a very interesting object. And so putting the power cone on here, she accelerates the flow onto the backside or the suction side of the blade, improving the lift, and the upside is improving the rotation of the rotor and getting power in the generator.
The reality is that the world needs more wind to meet its sustainability goals, and so that market will continue to grow.
Those turbines are going to have to be closer and closer to people's houses and to communities. But people do complain about wind turbines and noise, and so we're trying to help that as much as possible to drop the noise per wind turbine. The feather edge technology is very unique in the wind market. Owls want to be quiet when they hunt their prey. They want to be stealthy, and they achieve this with a specific geometry of their wing. So the feather edge is mimicking an owl's wing, which has a trailing edge fringe feather, which actually has this sawtooth configuration. So you have a sound wave being produced here and a sound wave up here, and they undergo phase interference. We're able to drop the noise by up to 4 dB.
So what that means is you can put wind turbines in more places without that annoying noise, but also you get more power out of the turbines.
It's a win-win situation for everyone.
There are 2 opportunities there. One is to incorporate our products into new builds, and secondly, once it's installed, we could actually go and retrofit it.
Retrofitting turbines allows for more power to be produced from already installed asset. It's a very cost-effective way of getting more renewable energy into the grid.
Biome's technology will really make existing and new renewable energy assets more efficient, more effective, and more affordable. The impact is to install our technology on tens of thousands, if not hundreds of thousands of turbines. If we get this right, and the products are installed on a more widespread basis, each turbine should generate more energy than it would have otherwise, which will contribute more renewable energy to dealing with climate crisis.
One of the big drivers of biomimicry is that it opens people's eyes to the awe of the natural world. Quite frankly, everybody should be looking at nature in some fashion if you're developing technology. There's something that everybody can learn.
We see the natural world not as a warehouse, but as a teacher, and hopefully in the nick of time. We're coming back to Earth and back to a new relationship with the rest of the natural world.
Human beings need power. We need sustainable green power.
We have to do a project, but we also have to work with the environment in order to make sure the asset is protected.
Nature is quite a powerful way of protecting all of us, whether it's humans, other species, or actual physical assets.
Zephyr is going to be one of the shining lights of ecosystem restoration for Pakistan.
There's a significant amount of population in Pakistan that does not have access to stable and consistent electrical energy. Being a country that is an importing country for fossil fuels for our power generation, but also not having stable access to fossil fuels can result in unstable generation. The lack of electricity has a significant impact on livelihood. It has an impact on education, it has an impact on health, it has an impact on wealth generation. So the basic social obligation should be met, and stability is required for us to progress individually and as a country. In Pakistan, we're blessed with phenomenal sunlight, good wind, good hydro. Renewable energy is a free resource that we have available to us, and we should take advantage of it. Zephyr Power is a 50 megawatt wind power project. That is a significant amount of electricity and a notable contribution to the grid. Construction began in 2017. We came online in 2019. We're using the Siemens Gamesa turbine. It's a 2.0 turbine with a wind diameter of 114 meters. It is the first project using this technology in Pakistan. Zephyr Power represents the new technology at the time for power generation. Zephyr is in the Indus Delta. We have to remain very conscious of the environment and the site, given that we are always exposed to tidal water flows. We have daily flooding on site, and as you know, you can't stop the water. So the thinking was done very early on, even before the first stone was put down at Zephyr, of how do we work with the environment. Civil infrastructure in particular can be damaged, and that can cause issues with regards to maintenance of the assets.
We were approached by Zephyr about investing in the wind farm, and through the due diligence process, we identified that it was built in part of the delta where a lot of the natural protection, that the mangroves that had previously been there had been removed. So we identified some opportunities to actually increase the resiliency of that investment through a nature-based solution.
We have done a significant amount of work to protect the existing mangroves, to revitalize mangroves which has been disturbed because of camels or because of disruptions due to fishing, crabbing and shrimping, and then also putting policies in place to protect the newly planted mangrove. It translates into protecting the asset because mangroves also protect the soil and solidify the civil infrastructure of the site.
We estimate that around $1 million of maintenance costs would have been saved over the lifetime of the project. Also, roughly around $6 million of avoided investment in new assets that could have been needed as a result of flood damage.
What is being attempted here is in between these wind turbines to regrow a forest that is of vital importance to our ecology and to the future of climate change for Pakistan. Pakistan is incredibly vulnerable to the effects of climate change. The heat levels in Jacobabad are already highest in the world. The water scarcity, the rising temperatures, the increasing salinity of our groundwater, the lack of water in our rivers, the melting of the glaciers are going to have profound impacts. From a global warming and climate change viewpoint, our delta requires as much reforestation as possible. The Avasina mangrove has aerial roots. If you look around at the site, you will see little finger-like protrusions out of the soil. Those are not growing the shoots of the plant. Those are the breathing aerial roots. So this tree breathes through its leaves, yes, but also breathes through its little protrusions. So the tree absorbs the carbon dioxide. It converts it into nutrients, forms of sugar, and feeds its roots.
Pakistan has set out some quite ambitious commitments that will help protect it from the impacts of climate, particularly through nature-based solutions. All of these can actually help to increase the resiliency of Pakistan.
Our site is an active fishing ground for the local community. We have 200-300 fishermen visiting the site every day. We have people catching crabs, we have people catching shrimp. The existing procedures we've put in place have already had a direct impact where 2 years ago, fishermen might have been catching 5 kilos of jhinga, of shrimp. Now they're catching 10 kilos. It's a symbiotic relationship that's critical for us to maintain this historical fishing ground for the communities, whilst also training the locals to protect the environment they have. The philosophies at Zephyr are really influenced by our stakeholders and by management. BII is our largest equity shareholder. They own just under 50% of Zephyr Power.
As the UK's Development Finance Institute, we are 100% owned by the UK government, and we're also an impact investor. We're very much focused on trying to invest in a way that will reduce poverty, deliver on the Sustainable Development Goals, and really ensure that all countries are moving towards a path towards sustainable development.
Zephyr really represents a mix of good technology, good environmental governance, good community relationships and governance, and individual ownership from the people that are here and from our stakeholders of the long-term strategy.
Pakistan and Pakistanis are probably leading the projects of mangrove restoration throughout the world. We have to work with humans and nature. It is a joint existence, and that's the only way forward.
Since the Industrial Revolution, if not before, energy has been at the heart of change, of prosperity around the world. Over the next 20, 30 years, we're going to see change on a scale that we've never witnessed before. We have many, if not most of the technologies we need to reach net zero. Battery storage, pumped hydro, and the role of digitalization that will manage supply and demand far more efficiently than we've seen today. We end up with an energy system sometime later in this century which is fundamentally different from the one we've had for the last century. The energy transition is effectively a complete rewiring and a replumbing of the energy system as it sits today. My name's Nick Waith and I'm the Chief Executive of the Energy Institute. So the Energy Institute is the chartered membership body for energy professionals around the world. We've got a very simply stated purpose, which is to accelerate a just energy transition to net zero. Every aspect of modern life is dependent on energy, and for most of history, fossil fuels have driven that, and today still account for over 80% of how we consume energy. I think we can get to a world where we have low carbon, secure and affordable energy and continue our way of life, but also share that prosperity with those that don't have it today. If we're going to solve this challenge and opportunity, we need the brightest minds from every sector working together, but then to grow them at scale and at pace. So the world is electrifying, and electricity demand around the world is growing at about twice the rate of overall energy demand. And we see that as whole societies begin to electrify. There's a huge role of technology. And actually, on the one hand, I would argue that we have many, if not most of the technologies we need to reach net zero today. So the pathway to net zero is not fully charted yet. There are many scenarios out there that you can go and look at. Number one, the continued growth in renewables. Renewables have grown at an exponential rate, roughly tripling over the last decade. And most forecasts out there would expect to see that continued level of growth, which has been driven by the continued decline in the costs of those technologies. The challenge clearly with renewables is they work very well when it's windy and sunny, but less so when it's not. And so there's a big opportunity around how we integrate those into the existing energy system, but also develop technologies that will help manage that variability. The role of batteries is going to be really important as we try to manage the variability of wind and solar in the energy system. So as we see exponential growth in batteries, we're also going to see huge demand for some of the key metals and minerals that go into those batteries: lithium, cobalt, nickel. And we know that many of those resources come from challenged geographies where there are human rights issues and other challenges. And so I think we're going to see an evolution of the battery chemistry, and in some instances that may create less dependency on some of those more challenging minerals. There's been a huge amount of focus and even hype around hydrogen over the last few years. And so there's been a lot of focus around the role of hydrogen in transportation, in heating. I would say hydrogen is more likely to play a role in heavy industry and really the areas that cannot be easily electrified. Today, the world uses about 100 million tonnes per year of hydrogen. Now that hydrogen isn't green, it's largely black or grey hydrogen, which is made from fossil fuels. We need to decarbonise where we're already using hydrogen. Fusion is a really interesting technology. It's how the sun works. It has huge potential for low carbon, almost abundant energy. But today we're still operating in the lab scale. We've recently hit some important milestones with fusion energy for the first time, very briefly providing net positive energy output. We need to develop that technology much further in the lab and then ultimately commercialize it. If we can untap the potential of fusion energy, it has got the potential to be a game changer. The transportation of energy has been critical for energy security. There is a role for more localized generation that is closer to the consumer and reduces some of that need to transport energy around the world. There are potentially different ways to transport energy around the world. We may have high voltage DC cables which allow electricity to be transmitted over many thousands of kilometers without significant losses. I think what's important in each of these choices is that we optimize the solution and don't just apply today's thinking into tomorrow's world. So the energy transition clearly faces some hurdles. I think firstly, we've got some huge challenges around the grid infrastructure. So if you look around the world, in almost every geography, the list of projects that are being built or being planned far exceeds the capacity of the grid. And we need to find ways of accelerating the ability to connect projects onto the grid by accelerating planning, permitting, and the physical infrastructure we need. We're going to have to build a lot more grid in the coming decades to really ensure we have an energy transition. Fossil fuels will continue to play an important role in the production of petrochemicals. But I do see a world where fossil fuels, first coal, and then oil and then gas, will play less and less of a role. I genuinely believe this transition is not only about reducing carbon, but actually it's about creating far more healthy environments everywhere we can consume and produce energy. It's about that energy being secure, locally sourced where it makes sense, and also more affordable than it is today.
With the predictions of energy demand growth nearing 50% by 2050, we need to come up with advanced technologies as a clean energy source to replace fossil fuels in the long term.
Economists know that innovation really matters to an economy. We know that it's important getting to net zero and to address climate change.
Geothermal is a very reliable source as the Earth is continually giving off heat.
We can absolutely harness the heat beneath our feet to drive and support the energy transition. There's a shift towards electrification of things. We need to get that electricity from somewhere.
Using technologies like geothermal, we can provide energy globally and reduce energy poverty.
Economic prosperity over hundreds of years has been driven in large measure by how we can capture and use energy. If you think about the Industrial Revolution that took us out of relative poverty, it was because we harnessed the power of coal. So how humans manage to capture the energy around them and use it to produce richer societies has always been very important. There's a vast amount of energy all around us all the time that we can capture and start to use. Now, some of those innovations will take longer than 10 years to come to fruition, but others are on the cusp.
Geothermal energy has actually been tapped for centuries. We have proven that it works a long time ago. It's just how to take that energy and expand it to different locations and to make it more environmentally friendly. My name is Lynette Liston, and I'm a senior geologist with Eavor Technologies, Inc. Eavor is a scientific technology company that's working towards pushing beyond the boundaries of the traditional hydrogeothermal setup and making it accessible and scalable everywhere. Unlike traditional geothermal plays, we are less dependent on circulating large volumes of water. We have a more benign system where we're not introducing or removing any contaminants out of the rock at deeper, hotter depths. We don't use advanced geothermal processes such as fracking to generate our own permeability or any other forms that would cause seismicity.
Eavor is basically a huge radiator miles below the surface that absorbs heat via conduction and brings it to the surface. That can be used for heating or producing power. I'm John Redfern, and I'm the co-founder of Eavor. Right now, we've got two that are breaking ground and starting to be constructed. One in Bavaria and the other one in New Mexico, which will be the world's deepest and hottest directional geothermal well ever drilled.
My name's Bailey Schwartz, and I'm the Director of North American Projects. Everloop is a closed-loop geothermal system. You basically build a heat exchanger, like a radiator underground. Cold water flows into one of the wells. As it travels through that radiator network of well bores, it's flowing at quite a low velocity, so it has a lot of time to pick up heat from the earth, because conduction is typically a slow process. On surface, the hot water can be used in a variety of different ways. You can either take the heat that would feed into a district heating network. Alternatively, you can use the heat to generate power. How deep we have to drill can really vary depending on geologically where we are and also who the end user is. For electricity projects, we'll try and target deeper, hotter temperatures. In New Mexico, we're looking at depths that are 5 to 9 kilometers deep, and that will get you to 300 plus degrees C rock temperatures.
We have a technique that we think will not only allow us to drill deep without melting all our equipment when it goes down, but also to drill faster.
It solves a lot of the challenges that traditional geothermal energy has really been constrained by.
Traditionally, our dependence on fossil fuels is based on our ability to have energy whenever we want it, whenever we need it, at a certain reliable amount. And green energy has always been painted as more of an intermittent energy source, where you have solar during the day, you have wind power when it's windy.
And people need more reliability than that. There is this gap that needs to be filled. Geothermal can provide baseload energy. It's really complementary to all the other sources that are available. And then when the sun goes down, we can ramp up an Everloop system, fill that gap, and really make sure that every hour of the day, the demand can be met.
You can put an Everloop system in an area and bring energy to people that would not necessarily have access to a grid. The reason we can do that is because we don't need the input energy that's required to cycle the pumps. Once the thermal function is actioned, it will keep cycling on its own without the additional added power required. This can enable more energy security and energy independence to different nations, so they are not tied to fossil fuel production from other nations.
There is no national or local or city or neighborhood independence without energy independence. By having local autonomy, you make it a better world, not just environmentally, but politically.
There's a huge demand, there's a huge market, and there's so many benefits to this technology that are going to improve quality of life for people.
We really are at a stage point where we could see a real renaissance in geothermal. So every town, every village, every country would locally have the energy source they wanted right under their own feet, right under the ground.
We're developing cutting-edge technology and every day pushing the boundaries to see closed-loop geothermal be a part of the global energy stack in the future.
Once we've got to net zero, we'll be in a far more prosperous world. Yes, we'll be dealing with the climate impacts because we're basically running 20 years too late. But if we get this right, we're in for a good second half of the century.
Cornwall has changed quite a bit since I grew up. We have our mining heritage, and they often joke that every time you find a hole in the ground, you'll find a Cornishman down it. Now Cornwall is at the leading edge of the next energy transition into renewable energy. So here we are running a business that's specialised with taking energy out of the ground, tapping into some of that history and heritage.
We're really underusing the natural energy of the sun. Being able to harness that solar energy that's stored in the ground, they can actually provide heating and hot water and do away with fossil fuels.
Nature is actually pretty incredible. All we have to do is be smart enough to take advantage of that natural energy source. The solution to heating our homes all this time has been right here beneath our feet. By using solutions like heat pumps, we can just take that low-grade heat energy directly from the ground, upgrade and use that. At the moment, more than 80% of our homes are heated by natural gas, which is burnt in the home, and it releases carbon dioxide, which is contributing towards climate change. Kensa is reducing the carbon impact of heating our homes. We are the UK's only manufacturer of ground source heat pumps. Ground source heat pumps in particular use a low carbon electricity. They're highly efficient, so the carbon emissions are far, far lower. Here we're very lucky that we've got the space to be able to do quite a lot of innovative solutions, but it's quite an interesting question to how we would do this across the rest of the UK. Imagining all those terraced homes in high-rise buildings with blocks of flats in some of our major cities, Bristol and Manchester and London. We can use the same approach called networked heat pumps, where we put the infrastructure for the ground array into the street as shared between multiple homes, and then you have an individual heat pump in each property, is effectively bringing the 21st century equivalent of the gas grid. So we can drill vertical boreholes, we can share boreholes in whole streets, and then we can put in very small miniaturized heat pumps into those homes. So this technology is available to everybody across the UK.
So we work with communities, particularly with local authorities and the more vulnerable in society that don't have a choice between what type of heating system they use. And we help the council to develop the feasibility analysis to be able to invest in ground source heat pumps and lift those residents out of fuel poverty. I think the key for us is to talk to organizations who own large amounts of properties and to tackle decarbonisation of heat at scale. Renewable energy options that's available to everyone is important. Heat pumps are expensive, heat pumps are disruptive. So was the gas mains when it was put in. Mass adoption of heat pumps would mean lower cost, lower carbon, and better air quality all around. I genuinely do not see any other solution that can be better than that.
So heat pumps work by moving energy from a source, in our case, the ground, which is all at roughly 10 degrees, to a sink, which is a radiator circuit.
The energy we collect from underneath the ground in the field comes through here, through the garden in pipework, and then goes into this shed here, and inside there is the heat pump itself.
The heat pump upgrades energy into usable heat. It's transferred to a gas called refrigerant, which is in its gaseous stage at that point. It then goes through a compressor where it's squashed, and then molecules are bumping into each other and they become hot. The hot gas is then passed across something called a condenser and then put in our radiator circuit where it heats your home. So in heating mode, we're moving energy from the ground into the home, and in cooling, we just reverse that. So we're moving energy from our home and putting it in the ground. The really exciting bit about this is that we can then use it for heating later.
A question a lot of people ask is, does it work all year round and is it warm enough in the winter? The collector pipes here are about a metre and a half underneath the ground, and at that depth, they stay relatively stable temperature. Yes, it warms up a little bit in the summer, and then all winter we take heat out. Day to day, you wouldn't know that we've got a heat pump. It's been fantastic.
I think it's quite poetic that we're surrounded by a place where previously we took minerals and coal out of the ground and burned it to create heat. And now we're moving to a solution where we only take heat out of the ground, leaving everything else untouched, making a positive impact on the environment.
We're right on the edge of this huge revolution in the way we heat our homes. The UK currently has around just under 29 million homes. By 2050, we're going to have to take out all of those gas boilers and replace them.
People make choices around what's cheaper right now, not thinking that those costs in the future are going to become a bit of a problem. So we need to be thinking about life cycle costs rather than capital costs. We need to be thinking about integrated technologies, car charging, battery storage, heat storage, different types of ways to heat your property and store it within your property.
When I think of what a decarbonised world would look like, you can afford to heat your home in the winter, cool it in the summer, and all of that is powered with renewable energy. By using solutions like heat pumps, we can actually live in a much cleaner, safer, lower carbon world.
The world is moving towards renewable energy. It's absolutely critical that we use as many renewables as possible so that we can reduce emissions, provide better sustainability for all our energy sources, and help to move towards electrification.
We have a lot of technologies now that bring a number of benefits, both in terms of electricity and in terms of other social and environmental benefits.
I think that almost everybody is now recognizing that as part of your business model, you really need to work with the First Peoples and to not just pay lip service to it. It's got to be a genuine relationship with genuine benefits for everybody.
Blue Earth is built on the premise that there are these renewable fuels available, the sun, water, but also the wind, and they will be there forever. There is tremendous efficiency in using them to generate electricity. So we are here because we believe that we can do it at scale and at a cost that helps people through the energy transition that we're all living through. My name is Grant Arnold. I'm President and CEO of Blue Earth Renewables. Blue Earth Renewables is an electricity generator. We build, own, and operate wind, hydro, and solar facilities in North America. Low impact electricity in what we do in wind, hydro, and solar is not only having no emissions during operations, but we have minimal impact to the environment around us during construction. Colton Creek is a run-of-river hydro plant. It is different from traditional hydro plants in that there is no dam. We take what we get, we run it down the hill, we capture that and divert it briefly through a facility that spins turbines at the bottom of the hill that then generate electricity, and we put the water back in a very low impact fashion. That electricity is sold locally to the grid, which in this case is operated by the province of British Columbia and used within the province. This plant is 15 megawatts, which is providing power for the rough equivalent of 6,000 homes, and it'll run for decades and decades and decades.
Traditional dams are not as sustainable as run-of-river for the reason they can displace communities, they can have very negative impacts on local biodiversity, and also they can lead to a lot of emissions associated with methane that is produced through the disturbance of the vegetation of large dams. Run-of-river hydro has less negative impacts associated with displacement of people or generally less negative impact on local biodiversity.
This was a traditional hunting and gathering area for people of the Squamish Nation, the set of peoples that have lived here for thousands of years. This was an area where, especially fishing, some hunting, but a lot of gathering was done by people. The Indigenous peoples of Canada are the original peoples, and we owe them respect and honor in any projects that we do. The land is so important to the people here that when we're doing something as impactful as putting a project on, it's very important to us to establish a relationship with the First Nation in whose territory that project is going to be placed.
When they heat up at the rock, it looks really red, right?
We approached them very early on the project, before we'd even had a full design, and asked how they would like to work with us on this project. We established an implementation committee, and on that implementation committee was an elder, a counselor, an employment person from the nation, as well as myself and the project developer. And we met every month to go over everything, to establish targets for employment, and to make sure that we were finding the right contractors from nation sources that we could use that would help out with the project.
There's about over 4,000 members in our nation. Well, the Squamish Nation, we always talk about the land is the culture and the culture is the land. We live off the land. To go through a cultural understanding and having that committee together avoids a cultural misunderstanding. We've met with Blue Earth a number of years ago. We sat down and we've talked about employment, training, education, naming, recognition, and bringing revenue for the nation. We talk about the grizzly bear habitat. We talk about the fishery, the spawning. I know that they're going to take care of it for our nation, for our children and our children's children. Just wanted to thank everyone for coming out on a beautiful day today.
The benefits to the Squamish Nation of this project were not only a royalty that they will earn from our revenues every year, but also employment and contracting. We had a number of nation-owned contractors who did things from security to brushing and planting, as well as a great number of workers on site. Total, we had about 13% of the workforce was from Squamish Nation, and that's from over 200,000 worker hours. Squamish traditions and customs were incorporated into the project, the main part by the artwork on a powerhouse building. This artwork represents the ancestors, water, land, animals, Mother Earth. For me personally, it's a passion that we respect the people whose traditional lands that we work on and live on. It just makes perfect sense that we work with them to do these things.
Renewable energy can be a really big contributor to energy security because it's a local form of energy. It doesn't require importing of fuels that may be subject to international prices. A more decentralized energy system can bring a lot of benefits. It can also create a more resilient system overall. We know we have all the technologies we need to decarbonize our economies. And these technologies are increasingly affordable, sometimes and quite often now more affordable than the higher fossil fuel alternative.
Renewables, wind, hydro, and solar are an absolute key part of Canada's energy future. People will consume energy forever, and if we can generate it forever with low impact, there is no better story.
We must remove our reliance on finite and destructive fossil fuels as our demand for electricity increases. 3/4 of global greenhouse gas emissions result from the burning of fossil fuels for energy. Renewables are the only way forward.
Global energy consumption is set to increase by 50% by 2050. Some estimates suggest that 10 to 20% of global electricity demand could be met by wave power. EcoWave Power, based in Tel Aviv, have developed a simple, clean, low-cost and scalable technology that may form part of the solution to the growing energy demand.
My name is Ina Braverman and I'm the founder and CEO of EcoWave Power. EcoWave Power is an innovative company that developed a groundbreaking technology for generation of clean electricity from ocean and sea waves. I was born in Ukraine. 2 weeks after I was born, the Chernobyl nuclear reactor exploded. I was one of the babies that suffered from the negative effects of the explosion. I actually had respiratory arrest, I stopped breathing, and a clinical death. So given a second chance in life, you definitely grow up with a feeling like I have a purpose. And I truly believe that wave energy is a good reason, especially when my first kind of chance in life was taken away by not so safe way of producing electricity. Wave power is just in its initial steps of commercialization. It's kind of the new kid in the block of renewables. It's a very huge source. According to the World Energy Council, wave energy can produce twice the amount of electricity that the world produces now. When the wave heights reach 50 centimeters, the system commences operation. The floaters are going up and down, and they're creating pressure in the system. That pressure is used to turn the hydromotor and the generator. We don't go into the offshore. We install on existent man-made structures. The environmentalists are supporting us because we're taking these bulky, huge cement structures, which are not so good for the environment, and we turn them into a source of clean electricity.
My name is Eavor, and I'm the Business Development Manager at EcoWave Power. As a new source of renewable energy, most of our challenges lie in creating policies and a legal framework for adopting wave energy in new markets. If we were to implement this worldwide without any obstructions, I foresee gigawatts of wave power being installed within the next decade. I don't think we have the luxury of waiting around anymore, and really now is the time to go ahead and make a change.
Here we can see the illustration of the project that we're currently building in the port of Jaffa in Israel. I personally love the fact that we're building this innovative project in the most ancient port in the world, the Jaffa port. There are many unused breakwaters all over the world. They're not prime real estate, they're just there. So there's no reason for us not to transform them into a clean energy source. My ambition is to see EcoWave Power's technology implemented in any location in the world that has a breakwater. Change is definitely not happening fast enough. I think that Mother Nature is kind of urgently calling us to wake up with all the floods and fires and natural disasters that we're currently seeing. In the end of the day, we all want a 100% environmentally friendly world. So the solution is in all renewable energy sources. I'm very excited about the future of EcoWave Power because I believe that EcoWave Power is a significant part of the world's future renewable energy mix. EcoWave Power is my personal passion. And I always say that passion is the greatest renewable energy source. So my ambition is to really see how wave energy is changing the world.
Lapate fojdačud, šečsalevin mašandaru mažzariutein mis fukat internetist fojdakenin at fukčizat mašandat maš biznesandat fukčat električstva talevin.
When Pamir Energy was formed in 2002, electricity was available to only 13% of the 220,000 households in eastern Tajikistan's most remote areas. Since then, Pamir Energy has restored 11 Soviet-era hydropower plants, which now generate 44 megawatts of electricity. This clean and reliable power source supplies energy to 96% of the local population, enabling sustainable economic development across the region.
Money maluat uz masxarah. Mam cafe shalom machuriach. مچوريخ ماميتشو شش فوق چیزات ماشان دنجا فوق سويت قتيدا ميكروفالنوفكا استفودا كنام خوي فوق الكتريش ويما холодильник خو فوق ماشا سويت قتتلوي قلوغ перо وقتي ماشان дару قين вод سويت навод печка юц вод жиз قتام чиз чуд шамам харит чуд целевин на электрическое вод целевин رو خدرت خیدم مثلا خو باج کاچ نواردود به شام رو قین بود قین وقتی نیم بعد حتی شش تلوین Pamir Energy mašar čišću dizga условия čuć fukći za televi sad foizo boare da dame dikid nadjužne.
Today, as we talk, 96% of the population has received uninterrupted power supply in the eastern Tajikistan. This actually means that the people can keep warm their houses in the winter harsh climates where it can be as cold as minus 52 degrees Celsius. This actually also enables hospitals to work and to provide the medical services to the people from the remote communities.
Кондитерская иногда, да. Кондитерская. Подит гейс машан шечаро чиз, молочный цех яст. Целевени да деварди урдамчо. Его и куерди урдамчут. Целевени. Фук чизарда урдамчут. شش سالين ماشان دارو ماش زريوتين مس فقط إنترنت استني سالين استفودا كني خو هرو даже دزغا مسيس سالين ماشان سوين دا أفغانستان مسويت تامين ماشان لا كارو دزغا كنا مدكيغا بيزنس خوريتا لا كيم بيزنس لا ماشان غولادي بيزنس سويدات إن شاء الله شت سالفات باشان شرويت ماشان.
Imagine you could bottle your sunshine, you could bottle your wind energy and ship it all around the world. That's the promise of hydrogen. We believe that there is no path to net zero that does not include hydrogen in some form. It is not a silver bullet, but it is a key contributor and enabler. We believe that hydrogen can make our world more sustainable, but also more secure and safer, and can bring about great benefits for our communities. I think it's an opportunity, and it will only turn into reality if we choose to act on it. As a little girl, I wanted to be two things: a teacher and a diplomat. And I think I'm very lucky because I get to do both. My name is Ivana Jemelkova, and I am the CEO of the Hydrogen Council. The Hydrogen Council is a global CEO-led coalition that brings together nearly 140 businesses and investors working together to unleash the power of hydrogen as a clean energy solution. I really believe in the power of humanity, in the power of problem solving, in the power of collaboration, and the Hydrogen Council and, let's say, the clean energy transition at large is exactly that place. Hydrogen is the most abundant element in the universe. The wonderful thing about hydrogen is that it can be also used as a fuel. It can be used as a clean energy solution. So today, most hydrogen is produced using fossil fuels. That means on a life cycle basis, there are emissions. Now, importantly, when hydrogen is used, there are no emissions. So even today, at point of use, hydrogen is zero emission. So really what matters is how we create that hydrogen, how we deploy it, and how we then take stock of its emissions from the beginning to the end. What we want to achieve is that the full life cycle is very low or zero emissions. That is the difference between clean hydrogen and the conventional kind of hydrogen that's been used for decades. The benefits of global trade in hydrogen and clean energy are enormous. There are parts of the economy that cannot be electrified, that simply cannot run on electrons. And that's exactly where hydrogen can help. Hydrogen can help decarbonize sectors of the economy that are out of reach for other solutions. When we scale clean fuels and start using them around the world, we have calculated that we could save 60 to 80 gigaton of emissions. If that doesn't sound like much, it's double the amount we produce every year from burning fossil fuels, from energy production. So today, the hydrogen conversation is a bit of a mess. We use words like green, clean, low emission, low carbon, sustainable, and we don't really understand each other. So really what we're talking about here is clean hydrogen. And we need to have absolute clarity on what we mean by that. How that hydrogen is produced, how the environmental and climate attributes of that hydrogen are defined, how we measure them, how we verify them, how we certify them, and how we bring them to the market. With that clarity, certainty, and trust, we can start trading. We can start moving hydrogen around, we can start importing, exporting, and we can really motivate investors to put money on the table. That is what will get the hydrogen system going. To set global standards, it's really all about the industry and governments coming together. When companies, businesses, governments, civil society, when we come together, we can really achieve formidable things. We will mutually recognize each other's information on the quality of hydrogen. And that is the foundation of the global ecosystem. We all work from the same technical specifications, and we all mutually recognize the receipts and the bills and the stamps. And that is the beginning of global hydrogen trade. The best way to create the future is to build it. Hydrogen is happening, the industry is walking the talk, and we are seeing an incredible, undeniable dynamic in terms of deployment and investment. We're now reporting the historically highest levels of committed capital, 75 billion, 7 times more in just the last 4 years, and over 400 projects pass FID, so 4 times more in terms of projects. Investment is absolutely key here. We are building a whole new dimension of the global energy system. Whenever I talk about investment numbers in hydrogen, I get big eyes. Those seem like massive amounts of money. But the reality is that they are just drops in the ocean compared to what we spend on energy today. And what we spend on many other things today. You know how much America spends on Christmas? $1 trillion. $1 trillion. Every year. We're talking about one Christmas. Consumer spending for one Christmas, buying us the way to deploying clean energy at that level. Look, if we want a sustainable future, we have to act like we want it. Oftentimes, we need to choose progress rather than perfection. We are at a difficult moment in the energy transition globally. In short, we are not on track. We are not on track. So the key question is, do we want an energy transition? Are we serious about our action on climate? Because if we are, we need to act like it. I'm a very pragmatic person. So when I hear the word hope, I look for evidence. And I know that I see evidence in the clean energy space. We have evidence. We have done this before. We, as humanity, have come together and solved some of the most difficult, complex international problems. So for me, it's not hope. For me, it's really that work, that opportunity to do something good, and I know that we can.
But at the moment, the best alternative we have in many people's mind to fossil fuels is hydrogen. So you need to store it as liquid cryogenic temperatures. That's colder than anywhere in our solar system. If you want to have it as gas, you need massive pressures. That's costing a lot of energy. And it's a nightmare to store and transport around. That's why when people talk about the hydrogen economy, we believe that the hydrogen economy is probably more like the ammonia economy. We say, turn it into ammonia. Ammonia is the energy vector. So you turn renewable energy into hydrogen. From there, you can turn that into ammonia, and that makes it much more transportable. So that's the first step. Then you have the second step.
About 70% of ammonia is towards fertilizer production. And also beyond that, ammonia is everywhere. So we use ammonia in our cleaning product, in our toothpaste. Also in pharmaceutical, ammonia is a very important chemical.
On top of that, ammonia is interesting for other reasons. We need more fuel and we need to get off fossil fuels. How do we do that? Ammonia burns as a clean fuel.
When it burns, you get water vapor and nitrogen. So it is currently being looked at as a direct replacement for diesel and petrol. And ammonia looks like a potential good use case for shipping in the future.
So when you ask, is ammonia part of a green transition? It's got to be. The trouble with that is ammonia today relies on massive industrial facilities, totally reliant on fossil fuels. We burn oil, we burn gas, we burn coal in order to make the massive pressures and temperatures that ammonia traditionally requires. Taking hydrogen and then nitrogen, activate a catalyst, and then you have it coming out the other end, ammonia. And that process is known as the Haber-Bosch process. NEOM exists to eliminate emissions. We want to clean up that process to make sure that all the ammonia being made is green. So NEOM is an entrepreneur, that's me, a former race car engineer and a nanoscientist, UBL. When I first met UBL, he started talking about nanocatalysis, and I was like, yeah, I kind of get catalyst, but you pass gases over a catalyst, and then it makes something else, in this case, ammonia.
I grew up somewhere close to Tarbo's plant. Every time you breathe, you can feel it. This is really something unpleasant. And then I went to university. I studied chemical engineering, and I feel like so now it's an opportunity to turn those heavy industry more sustainable way to make ammonia. Do the same thing, much cleaner way. That will be really a great thing.
The UBR Jumia system. We build small-scale reactors, we call them the Minion, which has a nano catalyst that he invented in. And that's powered by renewables.
Catalysis is all about the surface science. So if you can have loads of surface area in a small volume, you have a very good catalyst for ammonia production at a much lower temperature, much lower pressure. So we put the most promising catalyst in and then introduce nitrogen and hydrogen. And we monitored the gas coming out from the chamber. We detected some ammonia signal. At that moment, we thought this is a huge breakthrough, and then we got really excited.
What nanocatalyst does is it has much greater surface area. So that greater surface area means you can drop the heat, you drop the pressure. And what that means is you no longer need to rely on fossil fuels. And then we can power the whole setup with renewables.
So this is our Mark 1, our test reactor, effectively a scaled down Minion. We are taking nitrogen and hydrogen and combining them in the presence of our catalyst to produce ammonia. Once we've tested the catalyst here, we can put a larger quantity in the Mark II and test its ability to produce ammonia at scale. NEOM uses small 1 meter long reactors that produce 1 ton of ammonia a day. If you need to produce 20 tons, you just have 20 Minions. And unlike Harbour Bosch, the big plants that take 3 days to power up, we take half an hour to power up, and then we can start making green ammonia from the energy that's available. Our catalyst enables green ammonia on demand. The colour of the ammonia is a reflection on the way that feedstocks that go into it are made. So you need green hydrogen to make green ammonia.
So green ammonia on demand means you can decarbonize, means you can decentralize your global ammonia supply chain. And then finally, obviously, starting to help the hydrogen economy really take a foothold. So hydrogen is very good in terms of an energy source when you need it. How do you move that from A to B? Hydrogen, very tricky. Ammonia, we've got a global infrastructure. Our grandparents established this infrastructure we've been using for fertilizer over the last 100 years. It means that we can then tap into that network and move that hydrogen energy in the global south that have a lot of sun and a lot of wind up to the global north where there's more people and we consume much more energy.
We have technology to make a big impact when we come to solve the climate crisis.
The hydrogen industry is evolving. It's used in multiple different industrial processes. We have created this industry that's brought wealth and prosperity to many in the world, and we've built that infrastructure without having CO2 in mind. The promised land for hydrogen is that it can be decarbonized fully.
Clean hydrogen, miracle or mirage?
So, you're looking for sound bites, and now I'm like fearful of giving you a sound bite. Clean hydrogen is neither a miracle or a mirage. Clean hydrogen is simply a change in mindset and perspective. I believe clean hydrogen can be done. Clean hydrogen is clearly not a technical mirage. We have ways now to produce clean hydrogen in a variety of different ways at a variety of different costs. My name is Mike Adams. I am SVP of Capital Management at 8 Rivers. 8 Rivers is a climate technology company developing multiple different solutions to progress the industry towards net zero. The hydrogen industry is evolving. It doesn't happen overnight. We need partners who are in it for the long term, who are committed to providing the necessary financing, the vision and foresight that they want to use a clean hydrogen molecule within their current production. You put those things into sequence and there is a clear pathway to scale hydrogen globally. That's what gets me up in the morning, is coming in and thinking about how we're going to get those technologies to market and do so in a way that doesn't raise costs substantially. At the end of the day, energy has to be low cost because that's what creates the most human prosperity. Hydrogen has been produced for decades. And in that production, they're always looking to bring you the lowest cost energy molecule that they can. And to date, doing that meant that they didn't have to worry about CO2. So they designed processes where CO2 could simply be emitted into the atmosphere. For us at 8 Rivers, we think about clean hydrogen in terms of the carbon intensity of the molecule that's created. The lower the carbon intensity, the better. Hydrogen can be decarbonized fully so that it helps abate carbon in industries that are otherwise hard to abate and can't be addressed through electrification of renewables. What excites me is the mindset change. If you can think about energy production processes with CO2 in mind from the beginning, you come to fundamentally different conclusions about how you should be producing that energy. A lot of our innovations are based on this approach, where we separate the oxygen from air at the front of our process. We react that oxygen with a hydrocarbon molecule, and we end up with, in the case of clean hydrogen, we end up with hydrogen molecules and very pure CO2 that can be easily sequestered. This fundamental change in approach, we think, will lead to much more economic production of molecules that also capture the carbon, which current systems have to do after the fact. Clean hydrogen as a molecule has multiple applications. One of the most common right now approaches is converting hydrogen into ammonia. Ammonia is a commodity that can be used for many different applications, including fertilizer production. It's also being looked at today as a fuel to do power production to offset emissions from facilities that are otherwise burning very high carbon intensive fuels. Ammonia, by its nature, has no carbon inside of it. And so when it is burned or combusted in these facilities, it emits no CO2. So it's one of the pathways that clean hydrogen is finding to market. Project Cormorant, it's based in Port Arthur, Texas. Cormorant is producing, will produce clean hydrogen for direct conversion into ammonia, and that ammonia will be taken to overseas markets. Our hope is that as we scale and we bring the cost down, that ammonia can be used domestically for a variety of different applications. We're in a situation right now in the hydrogen industry where there's a clear dichotomy between the cost of producing gray molecules versus the cost of producing lower carbon molecules. We're going to need to bring investors to the table to actually bring the financing necessary to build these projects. In the hydrogen industry, there are a variety of different incentives provided to projects who can decarbonize the hydrogen production. Today in the US, for hydrogen production, there is a production tax incentive that has a different value for different levels of carbon intensity. In the EU, you have green bonds, which is trying to lower the cost of debt. All of these incentives are important to help push hydrogen production to the next phase, which is we need to take a step towards decarbonizing. We have to, at the moment, use the incentives that are available from both government sources and from early buyers to build those first projects that are ultra low carbon hydrogen and use those to learn. As a technology developer, we will look at those projects, learn how we can make them more economic, and the second, third, fourth projects will be even lower cost. It is that path of technological learning that will bring us down to cost parity with existing hydrogen production. This is how we get beyond the breakthrough, beyond just the innovation, actually make these projects real in the world. What will make it more real, and I think what will convince more people that it isn't a mirage, is our ability to get that cost down, such that it incents major players that they can build major infrastructure based on that technology. And I think that's when everyone will see it the way we see it, that clean hydrogen is not a myth or a mirage, that clean hydrogen can be real, it just takes hard work.
Shipping has a major impact on the marine environment. The only energy source we're being offered is one which is going to destroy the very future of organic life which we seek to enhance. We should be transitioning straight into green fuels.
The Green Pioneer now is the world's first dual-fuel ammonia ship. The benefits are widely known, and that is that it is a carbon-free fuel, and that it is produced principally from what we're breathing in with nitrogen and hydrogen.
This magnificent ship is the future of shipping. I'm Andrew Forrest. I'm the founder and executive chairman of Fortescue. I was originally a farmer and then eventually started my own company. I'm deploying that success into the most exciting industry there ever has been, and that's the transition to green energy everywhere.
It doesn't take binoculars to look far to see our mission is far from complete.
I really started considering the environmental impact of the company with my board of directors before 2013. It didn't really start with great conviction until I had a hiking accident and decided to put myself back to university, doing a PhD on the marine environment where the shocking ravages of climate change are being felt. And I came out of that convinced that there is an absolute urgent need to change. Ocean health is important because every second breath you have taken, it comes out of the ocean. We absolutely must protect it.
When we look at the contribution of shipping, you might say, well, it's only 3% of total emissions, it's not so high, but that level is going to rise with population growth and trade growth between 9 and 10% in the next decade or so. The Green Pioneer was a project really that was 2 years in the running till completion. We bought the vessel in 2022. Principal purpose then was to try to use a vessel to go and show to various ports so we can bring ammonia-fueled vessel into your port. We did some land-based tests in Perth. We ran ammonia engines there. That was very, very successful. Over a period of about 6 months in the conversion, we completed the project. The Green Pioneer now is the world's first dual-fuel ammonia ship, and this is basically a demonstrator vessel that has proven that it is possible today to use ammonia as a fuel. The benefits are widely known, and that is that it is a carbon-free fuel, and that it is produced principally from what we're breathing in with nitrogen and hydrogen, which we produce through electrolysis. So it has very, very strong green credentials compared to continuing to burn fossil fuel. You significantly reduce your carbon intensity. It is the fuel that will be replacing the fossil fuel in shipping. We got here, right here, brother, and we all made lots of friends. It's amazing, babe. So we came in here, see these docks here? We did the handbrake turn in the middle here. It's amazing.
So good, huh? Without any doubt, we can produce shipping fuel all over the world. That's, I think, incredibly important because we can mass produce it purely from the sun and the wind you're feeling right now rolling across your skin. That's wasted energy. We can convert that to shipping fuel. I think the biggest challenge we have is short-termism and deeply vested interests with solid knowledge gaps in their thinking, where senior politicians in countries are being told there is no way to a green future.
Shipping is a highly regulated industry. There's no rule book for the use of ammonia in a ship. When you go to a regulator, go to a flag state in Singapore and say, we're going to be burning ammonia in your backyard, Usually the first answer is, no, you're not. Hell will freeze over before that's going to happen. But I think what we really managed to do is we managed to show that we actually knew our stuff. As a mining group are anyway dealing with very complex chemicals and so forth. So our process safety systems are second to none. And then from one moment being quite negative, then they said, actually, no, we'd love you to come to Singapore. You're part of our energy fuel mix that we want to serve in Singapore. We delivered a project without a rule book. I think what was then the achievement of the project is we then helped write that rule book, so that enabled us to sail to COP28. And I think to date now, I think we've had more than 2,000 people visit the ship, from heads of states to leading marine biologists, of course, to leading CEOs as well. So this is really what the Green Pioneer is all about. We're wanting to trigger a demand for the ammonia to show that it's capable to build that market. We're wanting to show that the technology is available, and we're also show that it's actually feasible and permissible to use ammonia as a fuel. The next stage is to make sure that all the world ports are actually open to the use of ammonia in their port. Ultimately, green shipping has to involve people from both the supply end, the shipping end, the receiving end, the consumer end. We need to connect all those dots. Those people in the supply chain that are making the decision will cause that change to happen.
This presents the greatest single opportunity for investors and our shareholders that the world's seen in at least 100 years. We need vision. We need energy which doesn't destroy the planet. Let's act for our shareholders, let's act for our families, and we do that by going completely green.
This is the traditional territory of the Miwok tribes in the southern Sierra Miwok. This was their home. We came here 150 plus years ago. They've been here thousands of years. This was their pharmacy, this was their grocery store. Their livelihood was based on the forest. Forestry used to be a real industry in the Sierra Nevada, and it's appreciated to where it's not even really here today, and wanted to see that happen again. I think of nature as being, obviously, it's always producing a yield. I mean, that's what nature does. Nature grows. When we try to figure out what do we do to change this narrative, what we're talking about here of how to manage our forests and create a circular economy that we're basically seeking to find, no waste. Can forests be the engine room of the bioeconomy? In 1849, 1 million people came to California during the gold rush, first year. So all of a sudden, these forests changed in dynamic. They just saw the timber to extract. But that extraction model didn't really have all the science and understanding that this is an ecosystem. Fast forward 100 years, and we have a totally different forest that's really ready to burn. These huge overgrown forests in California that have ladder fuels, tons and tons of extra biomass that are burning more intensely and more severely, which never happened when the Native Americans were here. Wildfires have done billions of dollars of damage, millions of acres in North America over the last decade. It's a crisis. The chapter of what we had in the past of forestry with clear cutting and taking large trees and not reforesting or deforesting, that chapter is closed. The new era of forestry globally is one of balancing the ecosystem. My name is Tom Hobby. I'm a forest economist and an agrologist. We've been working through this last few years to help set up a bioenergy company here in California. Yosemite Clean Energy was a vision that I had a long time ago. I was frustrated. Which I saw forestry declining. Our forests were getting overgrown. We can actually generate revenues which will help support maintaining these forests, increasing the production of biofuels as a part of it. For example, in California, we have 50 million tons of biomass. We're using 3 to 5% of the wood waste in this state. For every ton of biomass that we actually take out of the forest, we can make about 1.7 barrels of oil equivalent. When you look globally of how much forests, on our planet surround almost every nation and every continent, we have a lot of room to grow this into being a significant replacement for fossil fuels. We could replace 3 to 4 billion gallons of diesel per year, which is probably 60 to 70% of the diesel demand just from our wood waste in California. We're trying to go back to a historical kind of ecosystem which is in balance. And we're trying to balance that ecosystem by taking all this wood that's out here that's probably going to burn if we just leave it here. We have a prescription and a plan. We don't rake the forest. We just thin the forest. We leave enough for biodiversity that every critter that walks, flies, and crawls or swims is going to have a home. We're trying to kind of mimic what the ecosystem looked like pre-settlement when the Native Americans were here. So all this wood here is a cost to the government. It's a threat for wildfire. Using our gasification technology, we can convert all this wood that you see right here that's just wasting away and costing money into a valuable asset. If you take a piece of wood and under high temperature, it turns it from a solid into a gaseous state. And that's the beauty. Once we get into that gaseous state, it's hydrogen, it's methane, it's carbon monoxide and CO2. And those are kind of the building blocks, which we call syngas, that really all these hydrocarbons that we're using from fossil can be replaced with a renewable resource. We can make biofuel, hydrogen, renewable natural gas, and aviation fuel from this wood. We have our business, we're building our first plant, but in forestry, one of the most limiting factors is transportation. It's really hard to get the fiber and the biomass from out in the forest down to a plant economically. So we can't scale up to have these million-ton facilities because the transportation costs to reach those facilities is just too high. So we need a more moderate scale, maybe 200,000, 250,000 tons. How do we continue and scale up the bioeconomy? Really starts with what kind of processes and technologies can utilize this wood to the highest and best use. But that scaling decision is a really important thing. Ecosystems are dynamic, they're changing. There's no one plan that fits all forest. We have to take the biomass that's available, what's economical, and then work with the financial community to how do we get these investments financed and how do we get this work done? So that has to be really intentional, and it takes good science. We have to have good inventory. If everyone around the world could assess how much biomass that are available in their jurisdiction, the bioeconomy could replace fossil fuel with biofuel and be carbon negative, which would be a huge benefit for our carbon goals and our global climate change initiatives. I feel like we have an obligation to manage these forest wells for future generations. Yosemite was my playground, my backyard. I can remember the first time that I came and I witnessed this mammoth monolith, the largest living things on the earth. Some of the tribal people I've talked to in British Columbia said, you know, their philosophy was never to take more than you needed and always leave behind enough for the future generations. If you take care of the forest, it will take care of you.